Imagine a vast industrial space humming with precise, synchronized motion. Steel arrives at one end, finished vehicles glide out the other. In between is a carefully choreographed sequence that turns raw material into a Tesla Model 3, consistent, quiet, and ready for the road. Let's walk the line from the first panel to the final handoff. We begin in stamping. Coils of high-strength steel are unrolled, edges trimmed, and sheets fed into towering press lines. Each stage shapes the metal a little more. Gentle curves first, then sharp body lines, then deep draws for door inners, hoods, and structural panels. Robotic handlers lift warm parts onto racks. Dimensional cameras scan for ripples and micro-deviations. Only panels within microns of spec move forward. Quality starts here, or it doesn't start at all. Next is the body shop, where pieces become a single structure, the body in white. Robots swing in with spot weld bursts. Laser welds stitch long, clean seams. Metered beads of structural adhesive boost stiffness and crash energy management. Floor pan, side frames, roof rails, and closures lock into place with extraordinary repeatability. On newer lines, large aluminum castings consolidate dozens of parts into single components, improving rigidity and simplifying assembly. The partially built Tesla Model 3 rolls through metrology cells, where blue light scanners and laser trackers read the surface in 3D. If fixtures drift or torques wander, the system self-corrects. Mass production is the art of building the same car perfectly, thousands of times. The paint shop is a world of its own, clean, controlled, and exact. First comes pre-treatment, meticulous washing, rinsing, and chemical conversion to promote adhesion and corrosion resistance. The Tesla Model 3 is dipped into an e-coat bath and electrified so protective material reaches every weld seam and cavity. After curing, robots lay down seam sealers along joints, arches, and gutters to keep noise and water out for years. In dust-free spray booths, paint robots trace pre-programmed paths, atomizing base coat into a fine, even mist over complex curves. A durable clear coat deepens gloss and shields against UV and chips. Under calibrated lights, inspectors check orange peel, gloss depth, and color match panel to panel. Passing here means the finish will look good anywhere. While painted bodies advance, the battery and drive units, the Tesla Model 3's heart and muscles, come together nearby. Battery modules start with precisely placed cells. Thermal interface materials are dispensed to wick heat evenly. Cooling plates and structural elements are added. Electrical connections are welded or bonded. Inline tests verify voltage, resistance, and isolation every step of the way. Modules are integrated into a robust pack with contactors, sensors, plumbing, and a battery management system that monitors cell health in real time. Sealants and torque sequences ensure a flat, square, leak-free enclosure. Pressure and insulation tests certify the pack before it ever meets the vehicle. Drive units, motor, gearbox, and inverter are assembled in compact modules. Windings, magnets, bearings, and seals are installed and measured. End-of-line testers spin the units to log torque response, efficiency, and vibration. The inverter gets validated firmware, and each drive unit receives a digital birth record that follows it for life. General assembly is where systems become a car, and it's the most human-centered part of the tour. The painted Tesla Model 3 glides onto the line. Wiring harnesses are routed through tunnels and clipped with audible tactile confirmations. Harness accuracy is non-negotiable. Airbags, safety systems, screens, and cameras all depend on clean signal paths. HVAC modules, brake lines, and the steering column are installed. Acoustic insulation lines the floor and firewall. The IP, instrument panel, arrives pre-tested for electronics. Seats are built offline: foam, frames, airbags, heaters, and connectors. So installation is lift and lock quick. Glass installation is a precision dance. Structural adhesives bond windshield, backlight, and roof panel. Robots compensate for minute tolerances. A millimeter here can be the difference between a quiet ride and wind noise at highway speed. The marriage station is a highlight. The body meets its subframe. Front and rear assemblies arrive with suspensions torqued and paint marked. The front carries the cooling system and front drive unit, if equipped. The rear may include another motor depending on configuration. The battery pack lifts from below on a guided platform. Alignment pins ensure perfect positioning while fasteners follow a strict torque pattern captured in the vehicle's data record. Minutes later, the Tesla Model 3 stands on its own wheels. Wheels are torqued to spec with tools that log every value. Thermal loops are filled and bled. The HVAC system is vacuumed and charged. The 12-volt system wakes the electronics while the high-voltage path remains safely isolated. Now comes software and calibration, the digital heartbeat. Over a secure link, the Tesla Model 3 receives its configuration, features, region, and the latest validated firmware. Cameras are aligned against targets. Radar and ultrasonic sensors are checked. Wheel alignment is set on calibrated plates. Doors are adjusted for flushness and closing effort. Panel gaps are measured. Trim is checked for squeaks and rattles using instruments and trained ears. The first start in an EV is the closing of high-voltage contactors. Systems handshake, screens settle, diagnostics turn green. The Tesla Model 3 rolls forward under its own power, but testing has only begun. On a rolling road dynamometer, the car simulates driving while stationary. Brakes are exercised. Traction control engages. Accelerator mapping is verified. Efficiency and acoustic signatures are measured under different loads. A multi-angle water test follows, simulating heavy rain. Any interior moisture is a fail. Simple as that. Then comes a ride and handling check. Either a quick loop on a track or a shaker rig that reproduces potholes, joints, and high-frequency vibration. The Tesla Model 3's quiet cabin makes tiny noises stand out. The point is to find them here, not on a customer drive. Detailing and final inspection close the loop. Protective films are removed. Paint is inspected under high-intensity lights, and micro-scratches are corrected. Upholstery is cleaned. Glass is polished. By now, the Tesla Model 3 looks perfect, but the story isn't complete without data. Each vehicle carries a full build signature, torque values, alignment numbers, leak-down results, battery test data, software versions, and pass-fail records from every station. Engineers use these data to spot trends, correct tool drift, and refine processes. Continuous improvement is a living feedback loop. Logistics bridges factory and owner. The Tesla Model 3 moves to staging, grouped by destination for truck, rail, or local delivery. Tire pressures are set for transit. Regional items are verified. The battery is charged to a level that balances long-term health with convenience on pickup. Delivery is the final handoff and the first moment of ownership. Vehicles are arranged for a strong first impression. Consistent gaps, clean reflections, flawless glass. When an advisor taps the screen and the Tesla Model 3 shows your name, a long, precise journey ends exactly where another begins. From steel coils to silent motion, from measured torque to measured miles, the build is not a single miracle, but thousands of exact actions, each verified and recorded. This is how a Tesla Model 3 comes to life, not just assembled, orchestrated.